Welcome to Prajim Technologies. I am Venkat. This is part 20, Static and Instance Class Members. In this session, we will understand what static and instance class members are and the difference between these two. We'll also look at a practical example explaining when you should and shouldn't be marking members static. Let's look at an example. As part of understanding static and instance class members, let's create a simple circle class. So class circle. And as all of us know, a circle class basically have two fields. One is the pi field and the other one is the radius. Okay, so let's go ahead and create these two fields. Okay, so pi is actually a float. So float underscore pi, and let's initialize that to 3.141. And let's create the radius field, and let's mark radius as integer, so underscore radius. Now, to initialize, by the way, float needs to have a trailing f. Now, to initialize class fields, we know that we need to have constructors. We have seen that in part 19, Introduction to Classes. So let's go ahead and create a constructor, and we know a constructor will have the same name as that of the class, and it doesn't have a return type, but a constructor can take parameters, which in turn can be used to initialize the class members. So public and the name of the class, circle, and let's pass in a radius parameter to this constructor, and we use this radius parameter to initialize this class field. So this dot underscore radius equal to radius, the parameter that we are passing into this constructor. So we have used a constructor to initialize the radius field, and pi field is actually already initialized here. And let's go ahead and create another method which actually can calculate the area of the circle and return it back. So public, and since we want to return the area back to the calling application, we need to have a return type. So let's have a float return type, float, and we will call this calculate area method. So what is this method going to do? Basically, this method is going to calculate the area of the circle and return the area. So, and we know that to calculate the area of the circle, the formula is pi r square, pi into radius into radius. So we can say simply return this dot, and in part 19 we have seen when we use this keyword we are actually referring to an instance of this circle class, an object of this circle class. So this keyword refers to an instance of this class. So this dot pi into this dot radius into this dot radius again. So what is this basically doing? Calculating the area of the circle and returning that. Now we have defined state and behavior for our class. The state is represented by these two fields and behavior is represented by this method, which can basically calculate the area. And what data is our class holding on to? Pi and radius. Now to actually use this class, we can go ahead and create an object of this class in the main method. So how do we do that? So circle c1 is equal to new circle. So we use the new operator to create an instance of this class, and when we create the circle object, we are calling this constructor and we need to pass in the radius. Let's say for example I want to create a circle with radius 5. So I get that, and then if I want to get the print the area back, what we can do, float, because we are getting float back. So float maybe area is equal to, we call c1 dot calculate area. Look at that, I'm using the instance of the class to basically call this method c1 dot calculate area. And if you look at the return type of calculate area, it's float. We are storing that in this variable, and if I want to print the area, we can say console.writeLine area is equal to whatever is written by that method. So now if you look at this method, it's a pretty simple one. All we are doing here is creating an instance of the circle class that we have created, and on that instance we are calling the calculate area method, which in turn will calculate the area for us and gives it back, and we are printing that area. So if we go ahead and run this application by pressing Ctrl F5, as you might expect, it returns the area of the circle. Now let's do another thing. Let's say I want to create another circle object. So let's create another circle object, but this time I'm going to call my object as C2, and I'm going to make the radius as 6. And since we already have area, we'll call that as area 1. We'll call this as area 2. So we're printing area 1 there, and we are printing area 2 here. Okay, so until now what we have done, we have created two circle objects, one circle with radius 5 and the other circle with radius 6. So let's go ahead and run this, and obviously it should print the area of the two circles. But for some reason, if you look at this, okay, it's printing, one circle area is 5, the other one is 6. But if you look at this, we are calling c1.calculate area. So that's why it's calculating the area for the same circle again. So we need to change this to circle 2. So let's go ahead and run this now. It should print the area of the circle 2. Okay, very simple example. But then there is something wrong here with this class, the way we have designed this class. Now look at this, whether you have created a circle, for circle 1 and circle 2, what's the difference in terms of the data that it's carrying? For circle 1, the radius is 5 and pi value is 3.141. For circle 2, the radius is 6 and the pi value is again 3.141. No matter whether if you create one circle or 1,000 circles, pi value is always going to be constant. It's not going to change on a per object that you are creating. So that's going to be static. It does not change on a per object basis. So when something doesn't change on a per object basis, then it is wise to go ahead and convert them into static. And there is a reason behind doing that. Okay. Now, before we do that, let's understand what's happening, in memory when you actually create these objects. Let's go back to the side. Now, if you look at this one, this class has two fields and we don't have static keyword in front of them. That means these fields are instance fields or non-static field. If I have put a static keyword, then this field is called as a static field. But the absence of static keyword makes them non-static fields or non or instance members or instance fields. Okay, now not only fields, your constructors, your methods, events, we haven't spoken about events yet, but events, delegates, all these basically whatever that can be properties that can be present in a class, they can either be static or instance members. Basically your class members like fields, constructors, methods, properties, etc. All of these class members can be of two types, either instance fields or static members. A member is called a static member if it has a static keyword, in front of it. Otherwise, it's called as an instance member. Now, when a member is an instance member, what's going to happen? We know that these two fields are instance members, and we are creating two circle objects, one with radius 5 and one with radius 6. So what's going to happen in memory is this one. Okay, circle 1. For circle 1 object, these two fields, we will have a copy of these fields, pi and radius. And if I create another circle object, pi and radius again. If I create another circle object, I will have a copy of pi and radius for that object. So keep in mind, if we create 1,000 objects, this pi and radius values will be duplicated 1,000 times, because each object will have their own set of those instance fields because they change on a per object basis. But if you look at this here, whether you created a circle with radius 5 or radius 6, pi value is going to be constant. It's not going to change. So it makes sense to actually mark this field as static because it's not going to change per object basis. So when you mark it as static, then in memory there will be only one copy of that pi which will be shared by all the objects that you create. Okay, so if we had made pi static and radius as instance field, then there will be a copy of pi which will be shared by all the objects you create. No matter, even if you create 1,000 objects, there is going to be ever one copy of the static field. It's not just with fields, even with methods. If the method is an instance method, then every object that we create will have its own copy of that method, executing. Okay, so if there is something that's not going to change on a per object basis, then it's wise to actually mark them as static. So in our example, it's wise to actually mark the pi field as static field. Okay, so the moment I mark it, okay, one difference between static and instance members, we have already known that, if a member has a static keyword in front of it, it's called a static member. Otherwise, it's called as an instance member. Now, I'm not referring to fields and properties. When I say class members, properties, fields, methods, constructors, all those things that can present inside a class are called as class members. Okay, so if these members have a static keyword in front of them, they're called as static members. Otherwise, they are called non-static or instance members. All right, so that's one difference. So the moment I make this static, look at what's going to happen. Okay, now this field has become static. Now the moment I made it static, look at this. You cannot refer that field with this keyword because remember, this keyword refers to an instance of this class, an object of this class. And remember, this pi does not change on a per object basis, so it doesn't make sense to call that using the instance of the object. Instead, you can refer that by the name of the class because it doesn't change on a per object basis. So there is no, it doesn't make sense to say c1.pi or c2.pi. You don't use an object to refer to a static member, you use the name of the class. So instead of using this keyword, and it's a compile time error to use an instance or this keyword to refer to a static member. So to refer to that, I can use the name of the class. And it's not only field, any kind of member. For example, let us say I have created maybe a public static void print method in this class, in this circle class, which can print the radius of the circle, let's say, or the diameter of the circle. We will not worry about the implementation at the moment. So if you look at this method, this is a static method because we have a static keyword. Now, if I have to invoke this print method, look at this. The print method is a static method, whereas calculate area is an instance method because it doesn't have static keyword. Now, to call calculate area, I actually have used the circle object C1 to call the instance method. Whereas if I have to call the print method, look at this, the moment I say C1 dot, I cannot see print method because there's no, it doesn't make sense to call a static member on an instance of a class. Okay, so if you want to call the print method, you use the name of the class, so circle dot print. Okay, so bottom line, another difference between static and instance members. Static members are invoked using the name of the class, and instance members are invoked using an instance or object of that class. That's why they're called as instance members. Whereas static members, the name of the class. And it makes sense, right? Because a static member doesn't change on a per object basis. So it doesn't make sense to actually invoke it on an instance of the class. So it perfectly makes sense to invoke it on the name of the class. And keep in mind, there is ever going to be only one copy of a static member in the memory, no matter how many objects you create. Okay, so that's another difference. Now let's get rid of this one. Okay, so I made this static, this pi field, a static field, and we are referring to that field using the class name. And now this program is actually a little more efficient because look at this, we have saved a lot of memory here. Float whatever is the size of the data type. If I create 1,000 objects, that much memory will be occupied by each copy. But instead now, since we made it static, there is going to be only one copy, even if you create 1,000, 2,000, 100,000 objects. So your program will run a little more efficient. Okay, another thing, your constructor can also be a static constructor. For example, look at this. This field is an instance field. To initialize an instance field, we use an instance constructor. Similarly, to initialize a static field, you can make use of a static constructor, something like this. And to make a constructor static, look at this. This constructor has an access modifier. I told you we'll be talking about access modifiers in a later session. Okay, but for a static constructor, you cannot have access modifier. So public static, let's say circle. And look at this, the moment I do that, and if I try to go and build a solution, access modifiers are not allowed on static constructors. Okay, so it's not allowing us to use access modifiers on static constructor, and it actually makes sense. Okay, you don't have to mug this or um, try and remember this hard. It makes sense because look at this. If you don't mark any class member with an access modifier explicitly, look at this, all I'm doing is I'm removing this access modifier. If I remove the access modifier of a class member, by default it is going to be private. And if something is private, you can access that only inside this class, inside the circle class. Outside the class, you cannot access that. Okay, so the moment I have removed the access modifier public, it has become private, so I cannot access this constructor outside of the class, and you will see there is a compiler error here. Circle does not contain a constructor that takes, because that's not visible. This circle constructor is not visible outside of this class because we removed that public access modifier, and by default if a member does not have an access modifier, it's going to be private, meaning it will be available only within that class. We'll be talking about access modifiers in detail in a later session anyway. So which means to initialize or to create an instance of this class, you have to invoke the constructor. Okay, because if you want to create a circle object with radius 10, you need to pass the size to that constructor, which will initialize your class field. So we are explicitly, actually this constructor gets automatically called when we are creating the C1 object. Okay, that's why it needs to be public. But a static constructor, you don't have to call that. The static constructor need not be called. Anytime you refer to any field, maybe a static field, if you refer to a static field, the constructor will be automatically called even before that to initialize the static field. Okay, so you don't have to call static constructors explicitly. That's why it won't allow the access modifier. If you put public, somebody will be able to call that constructor, and we shouldn't be allowing people to do that. Because why? They should be called automatically even before we refer to any of the fields within that class, any of the static fields within that class. That's why it doesn't allow access modifier. But anyhow, so why do we use static constructor? To initialize static fields. So I want to initialize this static field. So instead of initializing that there, what you can do is circle dot underscore pi equals 3.141 f. So keep in mind, static constructors doesn't allow access modifiers, and you have a static keyword in that, and static constructors are used to initialize static fields, and static constructors are called before instance constructors are called, and even before you refer to any static field. Okay, let's actually prove that point just a bit later, but now let's go ahead and see. So now with this change, what's going to happen? Your program, there's not going to be any difference within your program. It's going to work exactly the same way, except that we made this program a little efficient. Instead of having copies of pi field which does not change on a per object basis, for every object we are now having a single copy. So the amount of memory consumed by your application will be much lesser now when compared to how was it before, when both pi and radius are instance fields. I hope that's clear. Okay, static and instance class members. We have already spoken about this. When a class member includes static modifier, the member is called a static member. When no static modifier is present, the member is called as a non-static member or instance member. Static members are invoked using class name, whereas instance members are invoked using instances, objects of the class. An instance member belongs to a specific instance of a class. If I create 3 objects of a class, for example, I will have 3 sets of instance members in the memory. We have seen the examples of pi and radius. Pi being static, there will ever be only one copy of pi, whereas radius is an instance field. So for every different circle size that you create, you have a copy of that radius, radius 5, radius 6, radius 10, etc. So when we say, when we use the term class members, we are referring to all the things that can be present inside a class, like fields, methods, properties, events, etc. And we have also spoken about static constructors. Static constructors are used to initialize static fields in a class. You declare a static constructor by using the static keyword in front of the constructor name. Static constructor is called, yeah, this is again a very important point. Static constructor is called only once, no matter how many instances you create. But whereas an instance constructor is automatically called every time you create a new object. So if I create 1,000 objects, my instance constructor is called 1,000 times, whereas static constructor is called only once, because it just needs to initialize static fields once, which will be shared by all the objects that you create. We have seen an example for that. And static constructors are called before instance constructors. Let's quickly do a demo on that. So this is my static constructor. So before we actually console.writeLine, static constructor, and here we will say this is our instance constructor. So we will say instance constructor call. Now if we go ahead and run this program, since we are creating 2 circle objects, instance constructor should be called twice and static constructor should be called once. So first static constructor, then instance constructor, then instance constructor call. Okay, so let's go ahead and see this. So static constructor called, instance constructor called, that object got created, its area got calculated, and another instance constructor for the circle with radius 6 got created. Okay, actually your static constructor gets called even before you create an object, and even before when we try to access any static field. For example, let's comment out everything here. All I want to do is console.writeLine. Now if I want to print the value of pi that is present in this circle, but we need to make this public, otherwise we'll not be able to access that outside of the class. So I made that public. We'll be talking about access modifiers in a later session. So console.writeLine, since pi is a static field, I can just use the name of the class, so circle underscore pi. So now I'm not creating an instance of the class. Okay, so I'm trying to just access the static property of this circle class, and if we want to print that value, it should have been initialized. And where is it initialized? In the static constructor. So even before it tries to print the value of this one, the static constructor is called. So let's go ahead and run that. So look at that, static constructor called and pi value is printed. Okay, so to brief that up, static constructors are called before instance constructors are called, and even before you refer to any static field of that class, because they need to be initialized, right? So that's it. Okay, so static constructors are called before instance constructors. That's it for today. Thank you for listening. Have a great day.